What's going on? My name is Luke Barker. I'm here to talk to you today about the scientific method, the steps that have to do with the scientific method, and some of the other things that are used to really find out um, what you need to do to achieve either proving or disproving something. So here we go. So your scientific method, first it's going to start with asking a question. And this is usually based off of an observation. Uh, and you're going to be asking how, what, when, who, which one, why, or where. And kind of an in-between step that is included and that I use is like background research, which that helps just get you a step closer and kind of getting rid of any errors that could happen while doing a scientific experiment and research. Then that's when you make a hypothesis. So this is something that's an educated guess, and it's an attempt to answer the question that you have asked before, and then this is the question you're going to be testing. So in order to create a hypothesis for something, you're going to be asking, for example, if I change, the sunlight on the plant I have in my living room, then it's going to die if it doesn't get enough sunlight. So basically then I go to an experiment standpoint and I test my prediction saying that if I take it out of sunlight, that it's going to possibly die or reach towards the light, as plants do, to get the nutrients it needs. One of the really important things is that when testing prediction to achieve accuracy is keeping the conditions the same. So the conditions have to, stay the same. It has to, for the example of the plant, you have to make sure that, the temperature in the area it's at is the same day to day. And the time of day when the sun comes at a certain point, and you also have to take into effect, what time of year it is and all that, where the sun's going to be during a certain time of day. After you do the experiment, you're going to go back and analyze the data. Draw conclusions on what you have already you come up with. You're looking at all the data you have. You're going to have graphs, all different charts, numbers to incorporate that to back up your statement is, if I change sunlight, will the plant die? And that's a huge question. Most of the time as an experiment that you come up with is going to fail right away. And that's why these things keep happening and happening and happening. There's hypotheses that are researched still till this day. So, and it's always ever changing and new information is found, and that's why we continuously and effortlessly want to do this, so that way, we're trying to be the most accurate as possible. And that's the scientific method broken down into kind of your basic steps. Now, I want to go into talking about one of the things that, is needed in order to do the scientific method, and that is deductive reasoning. It's something that's a logical process where it's a conclusion-based thing, and you're just assuming that multiple premises are true. Something that I found is called, it's like top-down logic. So you're going to start at the top and try and just see what all the possible outcomes are, and follow that. Then there's inductive reasoning, which is something that is a logical process where there's multiple premises and they are all believed to be, or most combined together to make a conclusion. These are used for prediction of forecasting or behavior, to see what's going to happen from a situation. But all in all, when finding and getting, starting your hypothesis and everything. Okay, and now I'm going to be talking about 3 things that can sometimes get moved around or misunderstood in a way. So I'm going to give you some like the definitions of these things and some examples to go along with it. It might be repeating myself as far as definitions go, because some of these have already been used in what I had said earlier. So a hypothesis is a proposed explanation based on limited evidence, and this is where you're starting to investigate. So like I stated earlier, saying if I put the plant, if I put the plant in a different place in sunlight, will it die, or flourish? Something along those lines. And then let's go into a theory. A theory is ideas intended to explain something. It's usually based on some type of general principle. It's an independent thing that's trying to be explained, and it's testable, but it's usually, a theory is forever going. It never really is a constant. And then also there's laws. Law. So, we all know what law is, but it's a system of rules to regulate actions. The laws of gravity, something that is clearly there and that is unchangeable, and can't really go any further. But as far as law, it's mostly based off of a system of things, and is placed in sorts to make things, I guess, simpler and understood. Yeah. And then sometimes, obviously, like with certain laws, you have things where there are things as far as laws in nature that we're disrupting as people, we see the consequences from it. Global warming, for example, we're seeing changes in atmosphere and weather overall throughout the entire world. So we're changing. These things are changing only because there's an outside factor imposing on it. But yeah, so that is generally what your hypothesis is overall, as far as your scientific method broken down, and also just different things to take into consideration while creating a hypothesis and doing scientific research, and just to define between three things that can get confused: a hypothesis, a theory, and laws. So it can get mixed up all at once. So hope you enjoyed the video. Hope it's good.